Hi, this is Tina again, talking to you at the moment about angular measurements. So we're still in Lab 1. Talked first about math a little bit, then we talked about scientific notation. Another sort of important thing to talk about, which is sort of math-y, is angular measurements. They're really important within astronomy to talk angular measurements, and I'm going to tell you why. So here is a circle. So our circle is 360 degrees, if you remember that. So here's our center, here's the radius, and then if we go all the way around, there's 360 degrees. So we can break up that even further, kind of like we did with the scientific notation when we're talking about the metric system and how we're dividing things smaller. So 1 degree is 60 arc minutes, which we can also write with one little tick mark here. So this one little tick mark also means arc minutes. So just like an hour has 60 minutes in it, 1 degree has 60 arc minutes in it. And then 1 arc minute can be broken down further into 60 arc seconds. Kind of like a minute can be broken up into 60 seconds. And we denote that with 2 little tick marks. Okay, so it's kind of a little bit confusing, but I'm going to try to clarify that. So if we talked about the celestial sphere in lecture 1, and we talked about angular separation and angular measurements as well, but for the lab, I wanted to do it again. So if this is our horizon line, and then if we look directly above us at the zenith, we have a 90 degrees of separation, okay, because it makes a 90 degree angle here. And you might be asking yourself, well, why do I need to know that? Well, we can measure the distance of an object, say the moon, for instance, moon here. We can measure the distance across a moon, and I believe that is 0.5 degrees, or I'll have to look. I actually don't remember. I'm going to look it up right now as we're talking. So we can also talk about like a galaxy. A galaxy will be, like say 35 arc minutes across. Or we can have 2 stars that are right next to each other, and we can say they are 1 arc second from each other. So there's 2 things. So we talk about how big an object is or how much distance they have between them. Okay, it's a half a degree. I got it right. Woo-hoo. It's 31 arc minutes. 31 arc minutes or half a degree. Ooh, I got it right. Anyway, okay, so the 2 things we do with these angular measurements, we say how big an item is. So, and in the lecture, there was the bunny, which was 30 arc minutes, and the shark, which was 60 arc minutes. Or no, those were degrees. I'm sorry, that was 30 degrees or 60 degrees. And then, but that goes, we can make really, really small because things are really far away, right? So then how big an object is, so we can say how big the moon is, how big the sun is, how big Jupiter is, that kind of thing. Or we can talk about how much angular distance there is in the sky. So these 2 stars right here that I said were 1 arc second apart in the sky, that's on the celestial sphere. How much distance there is in reality, one could be here, one could be way back here, but angular distance wise, oh, I can do this. Angular distance wise, they look like they're really close together. They look like they're really close together, but my hand is back farther. I really am not very good at that. Anyway, let me do fingers. There we go. They're still close together, but one is back farther by a lot. Okay, that's really hard. Anyway, so, and that's the weirdness about the sky. The celestial sphere makes everything look like it's projected on the inside of your basketball. And so the distance that they have on the inside of the basketball is 1 arc seconds, but in reality, they could be millions and billions of kilometers apart. Okay, so it's kind of weird. So if one object is here, but in the sky, they look like they're really close together, but this one is actually way back here. It's just that you looking at it I can draw an eyeball. They look like they're actually really far apart, but the way they look to you, I'm getting all excited about how the way they look really close together. So they look like they're about that far apart. It's just a weird thing about the sky. So anyway, so that's angular measurements. If you have questions, let me know and I will talk to you soon. Wait, I said that too early because now I have to turn off the video recording if I can even get it done. We're having fun. It's all good. Everything's good. Oh, I have to stop the share. Yeah, live idiot on. I didn't say that. Okay, anyway, talk to you soon.